Hello. Today we're going to do some examples using sum and difference formulas. This is basically a review of what we've done. In the past you haven't used the tangent formula, so we'll look a little bit at that. And you were able to do all of last week's work just using the sum equation. So we're going to use the difference formula sum today as well. And we'll also use it to solve. So here we are. Here's our problem set that we're going to look at. I have the answers in the Word document that you'll have, but the examples and how to work it out will be done only in the video. So first off, let's find the exact value of pi halves, or pi 12s. So there's two ways of looking at this. If you're good with fractions, this is 1/12. And how do you get 1/12? Well, you take 1/3 or pi thirds subtracted by pi fourths, and that's pi 12ths. If this isn't immediately obvious to you, or you struggle with fractions, the other option when this is in radians is to convert it to degrees. And if you remember, you basically multiply this by 180 over pi. The pi's will divide out to 1, so whatever this fraction is times 180 is essentially what you're doing without the pi. And we get 15 degrees. And then it's easier to see that for most people, that if you take 45 degrees and subtract 30 degrees, you are at 15 degrees. So we will be using the subtraction formula in this case. So tangent of pi 12, so we set up our equation, is equal to the equivalent of tangent of pi thirds minus pi fourths. I'm using the radians here because we started in radians, but you don't have to. You could convert this to degrees. They're equivalent statements. So then we're going to use our formula where it is tangent of the first minus tangent of the second. And because this is a subtraction, this is a subtraction. And because this is subtraction, this is addition. So the opposite sign on the bottom and the same sign on top for tangent. And then 1 plus tangent of the first term times tangent of the second term. I realized that there was a sign there for some reason. I fixed it. And then we just evaluated this. Well, tan of pi thirds is the square root of 3. Tangent of pi fourths is 1. So we plug all that back in, plug that in. So we have square root of 3 minus 1, and then 1 plus square root of 3 times 1, which is just the square root of 3. And now we have a little bit of math we're going to do, because this can be simplified, and we ought to. So what I'm going to do to simplify this, to get the radical out of the bottom, if you remember, this is called rationalizing the denominator, we multiply by the conjugate. So this is 1 plus the square root of 3, so here we multiply by 1 minus the square root of 3. So we multiply by this fancy 1 minus square root of 3 over 1 minus square root of 3. And I sort of show how this works out over here. Square root of 3 times 1 is the square root of 3. Square root of 3 times the negative square root of 3 is negative 3. The square roots basically cancel out. Then negative 1 times 1 is negative 1. And negative 1 times the negative square root of 3 is positive square root of 3. And the reason we do this conjugate is it basically allows the middle terms to cancel out. We don't have these. So we have 1 minus 3 on the bottom. And then we're going to simplify that. So we're going to get 2 square roots of 3 minus 4 over negative 2. Then we can divide that out. So the negative 2 divides out with the negative 4, and that gives us 2. And the square root of 3, 2 square roots of 3 over negative 2 turns into negative square roots of 3. So this is the simplified form. This is our final answer. It's the exact value of tangent of pi 12ths. If you want, when you're done, in your calculator, you can type in tangent of pi 12ths, make sure you're in radian mode, and then type this in, and those should be the exact same decimal value. But I just want to reinforce that this is the only answer that's acceptable when it says exact value. You cannot give me the decimal approximation. Our next example, we're going to simplify some sort of trigonometric function that has a sum, and in there's a variable and a constant term. So we're going to just plug this into our formula. So tangent of the first plus tangent of the second term. And then once again, this is plus because that's plus. This is minus because that's minus. Plus. This is the opposite. This is the same. And then 1 minus tangent of the first term, tangent of the second term. Now we just evaluate all this. Tangent of theta has to remain the same. Tangent of 3 pi is 0. This is the equivalent to pi. It's coterminal with pi. And so, and that also gives us our values down here. Well, tangent times 0 is nothing. Tangent plus 0 is tangent theta. So we have tangent theta over 1. And so our answer is tangent theta. So this is a fairly easy problem. You just have to recognize that it falls into our identity, our sum and difference formulas, and you just plug it into the formula and simplify. All right, now let's look at our last example, solving. I know that's everybody's favorite thing to do. And this looks horrible, and don't worry, it will look worse in just a second. But we have find all the solutions of sine of x plus pi over 4 plus sine of x minus pi over 4 equals -1. And what you should recognize here is we have two things that are set up in the sum or difference formula setup. We have something plus something else within a trig function. So we're going to plug this into the sum and difference formula and this into the sum and difference formula. And so this is going to be a little bit long, and this is what we get. We get sine of x cosine of pi fourths plus cosine of x times sine of pi fourths. That's all for this term. And then we have plus, because there's a plus sign. If this was a minus, you would put a minus here and then parentheses around this. But plus sine of the first term, x, minus times cosine of pi fourths. And then this is minus, so this is minus. Cosine of x, sine of pi fourths. And this still equals -1. So this looks horrible, but it simplifies fairly nicely. You'll notice that we have two of the exact same things. One's positive and one's negative. So this and this are going to cancel out. And these two are the exact same thing. So we're going to have two of those. So this really just turns into this. As bad as that is, this is much simpler. So we have 2 sine of x cosine of pi fourths equals -1. Well, cosine of pi fourths happens to be a number. It's the square root of 2 over 2. So we have the square root of 2 over 2 times 2, which is just the square root of 2. The 2's divide out to 1. So we have the square root of 2 sine x equals -1. And at this point, you should be relatively comfortable solving this. We divide by the square root of 2. We rationalize the denominator. Where is this true? Where on the unit circle is sine of x equals -square root of 2 over 2? Well, it's true at 5 pi fourths and 7 pi fourths. But because I said find all solutions of, we're going to expand this to the infinite solution set, 2k pi plus 2k pi, where k is an element of the integers. And so this is our final solution.